Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Snyk. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead of us, but first, I have a couple of housekeeping notes. First off, today's session is being recorded, so if you miss any of our conversations, say you join us late or maybe you had to leave a little bit early, the recording will be made available shortly after we conclude our live seminar today. You can also find it on the DevOps website at devops.com/webinars. It should be there by tomorrow. Any questions you might have for our speakers, we want you to direct those to the Q&A tab on the right side of your screen. And feel free to use the chat tab to talk with the rest of your audience members or just let us know from where you're tuning in. Finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is integrate security controls wherever you build applications. And I'm joined today by Craig Dent, Senior Solutions Engineer at Snyk, Tony Trin, Senior Partner Solutions Architect at AWS, and Andrew Pankavicius, Senior Product Manager at Atlassian. And it is my pleasure at this point in time to turn the floor over to Craig. But thank you all so much for being here with me today.
Thanks, Cody, and welcome everyone. Thanks for joining today. We look forward to talking to you about our capabilities and the workflow around security that we offer. So our agenda today, we're going to start off just by talking a bit about what constitutes an application in the modern world and how that's changed. Then we're going to spend some time talking about Snyk's unique approach to application security. Then I'm going to throw over to Tony, and Tony from AWS is going to talk about some of the Devsecops practices on AWS. And then Andrew is going to talk about how you can secure your SDLC using Snyk and Atlassian. And then finally, we're going to jump into a bit of a demo, and we can show you exactly how that works and what it looks like. So to kick off, what constitutes an application? Now that's changed with the advent of cloud and with cloud deployment. The application has transformed what was traditionally infrastructure into code. And that means we now have different needs, different ownerships, and different responsibilities that go around securing it. Traditional application security tools, they focus on finding vulnerabilities in the functional code of the application. And then securing the infrastructure as code components, that's often done at runtime, which parallels some of the older models where those components were actually physical infrastructure. But as the cloud native application stack has emerged and code is defining things like the application containers, the services and the infrastructure itself, that code has become an essential part of the application, and it's created by developers and therefore must be secured as part of the application security process in order to avoid vulnerable configurations and vulnerable components being deployed into production. And so the code that makes up the application, as I mentioned, has changed. And so in order to make sure that code is secure, we need to look at a number of different aspects. So traditionally, what the application teams have done is they've scanned their custom code in order to look for vulnerabilities and to fix those issues. But a modern application is made up of much more than just the custom code that the developer writes. And somewhere between 80 and 90% of the code base is actually the open source libraries that get pulled in to provide some of that common functionality. And of that open source code, 80% of the vulnerabilities are not actually found in those direct dependencies that a developer has defined. They're actually found in what we call transitive or indirect dependencies. So this is the case where we use a library, an open source library, and that open source library requires other open source libraries. And often we're blind to those libraries that are being pulled into our application. So it's very important that we understand and we have some tooling around securing those open source components. And the main reason for that is the attackers are often building exploits that go after vulnerabilities in the open source libraries, because the return on investment is a lot higher. If they can build the exploit once, there's thousands, if not millions, of potential applications that they can look for holes in. And then as we go down the iceberg stack, we also have to consider the containers themselves. So the applications are usually in the modern world being deployed into a container environment, and those container libraries have their own vulnerabilities in the Linux packages, etc. So that kind of expands the scope of the security of the application itself. And then finally, the infrastructure as code piece. This is where we're using templates in order to define and spin up our infrastructure. That could be things like Kubernetes YAML files, for example, for deploying containers into a cluster. It could be Terraform files, for example, for spinning up the cloud resources. It might be more proprietary, like CloudFormation or other technologies. So again, this is a common source of vulnerabilities. The number one security vulnerability, according to the research, is misconfigurations of cloud resources. So again, it's very important to find those issues early in the life cycle and fix them before the actual resources get spun up. So Snyk, we believe, has a unique approach to this problem. The first and foremost is that we're a developer tool. So we're a tool that's built for developers by developers, and we try and meet the developer where they work. And what that means is, rather than requiring them to move to a separate tool in order to assess the security of their application, we want to provide that information in whatever tool they're already working in. We want to provide actionability. So we want to automate the fixes. When we find a problem, we don't just want to tell the developer that there is a problem. We want to actually tell them, one, how to fix it, but automate those fixes, provide them the fixes that they can then merge back into their code base in order to eliminate the vulnerability. And all this has to be underpinned by a comprehensive security database. So you want to make sure that you find, when new vulnerabilities discovered, you're able to determine whether your application has those as soon as possible. And you also want to make sure that it's comprehensive and that you're covering all the vulnerabilities. So again, this is one of the key strengths of Snyk, is we have a research team that are using some of the public databases, but they're also uncovering and researching and discovering new vulnerabilities all the time. So with that, I'm going to hand over to Tony, who's going to take you through the next stage, which is Devsecops practices on the AWS public cloud. Thanks, Tony.
Thanks, Craig, for sharing with us, the change in building modern application, as well as how Snyk can provide significant value for our engineer and developer. Obviously, it would be incomplete when we talked about security and modern application without mentioning about Devsecops. So technically, what is Devsecops? Some of you may be very familiar, some are new to it. So let's get everyone on the same page, right? So Devsecops, and look, this is a very loose definition. You may have a slightly different definition, but from AWS, we understand that Devsecops, is a combination of cultural philosophy, practices, and tool that exploit the advance made in IT automation to achieve the state of production immutability, deliver frequently, and enforce security policy in an automatic manner. Right? And the question we usually ask is, why is it important? Why care about Devsecops? Right? The reason is because there's an increased number of cyber attacks and uses of open source, as Craig had mentioned. And these are playing a huge role in software development. It's very common that, developers nowadays have used some old version that may be vulnerable to security attacks. I'm sure you've heard about Log4j incident of last year, right? And of the incident that it brought along. Now, it becomes even more critical for federal or public sector organizations to comply with different security standards, like OWASP NIST, right? But in the traditional approach, we used to keep security toward the end as the issue arises, right? With Devsecops approach, we're shifting that leftward. What I mean is that we shift more resource away from production on the extreme right and put more security concern into the design phase, testing phase, and building phase across the software development lifecycle. And by doing that, we reduce the organizational risk, the security risk, and also reduce the overall cost of the SDLC process. And the end state is that us, everyone can move fast and stay secure. Well, in the past, you have to choose between move fast or stay secure. Now with Devsecops, you can achieve both, move fast and stay secure at the same time. Now, let's talk about some of the DevSecOps practices. And look, this is all principles. So it's applicable wherever you run your application. It could be, on AWS or, on your private cloud, wherever you choose. But these are all, principles. So they are universal, right? First cap of the rank, I'm sure most of you are already familiar with DevOps and continuous integration, continuous delivery, or CI/CD pipeline, right? In which CI is the practice of integrating changes and testing them frequently, and CD refer to automatically preparing software build for production releases. DevSecOps is achieved by integrating and automating the enforcement of preventive, detective, and responsive security control into this CI/CD pipeline. Applying the very same key principle from DevOps, the only additional that DevSecOps bring to the table is that we are collaborating with security team from the very initial stages of the SDLC and incorporating security best practice throughout this the SDLC lifecycle with dev team and ops team best practices still in place. Apart from CI/CD or DevOps, obviously, I'm sure you're familiar with, microservices architecture, where different team, actually each team build a single application as a set of small services, with each service scoped to a single purpose, right? And when microservice architecture is applied, and microservice are built with least privilege security, it can reduce the overall risk of single application being compromised, or reduce the blast radius for short. Similarly, another DevSecOps best practice is infrastructure as code. Should be very familiar to most of you, by which infrastructure is provisioned and managed using code and software development technique, so they can be versioned, deployed in a repeatable way. From a security lens, it also provide an audit history of code over time and documentation of existing infrastructure. It can be evaluated through security filter. Now, lastly, you need logging and monitoring tool to understand how the code and the infra changes impact user, and for troubleshooting and gaining insight. So with all of this security best practice incorporated in each of the software development component, all of the team, the dev team, the security team, and the ops team can better collaborate as tooling, bring better workflow and clearer responsibility of each team. And I understand that we could easily spend hour after hour discussing on each of these practices. So this is really just 10,000 feet view. But within the scope of today's section, let's just focus on the most popular aspect of DevSecOps, which is how do we integrate security into our CI/CD pipeline? Because this is where you can gain most of the value without investing too much of your time and effort. Getting off the low-hanging fruit for your team and your company. So from AWS, our understanding is that when you want to integrate security into your CI/CD pipeline, we looked at three pillars. First is the security of pipeline, security in the pipeline, and the enforcement of the pipeline itself. Right? Now, I'll go through each of this and then explain briefly what I mean. Firstly, security of the pipeline itself. This aligns with infrastructure best practices. So to start with, you should have your pipeline defined in code. Not only this will help you to scale your DevSecOps practice, but it's also provide an artifact to review for security. You can prevent user from modifying an existing pipeline, and they can only do that through code. And this ensure security measure are not removed or modified out of processes, right? And there are other consideration that you need to make to secure your pipeline as well. For example, authentication and authorization. One of the last design decision we talked about was considering pipeline permission. So just like infrastructure you support now, you must determine who can access what and what can they do. Right? Many organizations tie their AWS user with an existing corporate user store, such as Active Directory, or some company can use Google G Suite, or some use Amazon Cognito or SSO, and they use all of this identity provider to provide a role-based access control to grant access to different services and application and user. Right? So once you have got your authentication and authorization in place, you need to think about encryption. For security reasons, many of our customers also follow the thought process of encrypting everything. In AWS, many of our services are encrypted by default or have an option to encrypt the data address. Take advantage of this and utilize it within your pipeline as well. So you want to ensure all of the service you use are using HTTP for encryption in transit as well, so that your data is protected. And you also want to use integrity checking for your package to make sure that they have not been tampered with. And there's also other area like alerting, logging, or configuration management and patching, which I will not dive too deep into. Obviously, as I mentioned, this is a very high level. I'm more than happy to talk to you in a different meeting to dive deep into each of this area and how AWS can help you to achieve those, what kind of native service you can use. But obviously today, the focus of the section is on the value that Snyk and Atlassian bring to the table on top of the foundation that you already have on AWS. So yeah, feel free to reach out if you have further question around each of this area. Let's move on to security in the pipeline for AWS and what that means, right? So security in the pipeline is all the security tooling and scan that will be run within your pipeline to analyze and assess your application code. It starts all the way from source code control throughout building, testing, deploying, and monitoring your application, right? So with source code control, you want to make sure that you do code analysis to protect sensitive information. With building your code, you want to make sure that you check all the dependency and make sure that all the dependency are good. There's no security loophole. And then when you move on to testing, you want to scan for vulnerability. Or once you're about to deploy, you already have your artifact. You want to make sure that you do a hash verification so that the artifact is really integrity and it has not been tampered with. And you also want to set up automated alerting to monitor the performance, the security, the access of your application. And as I said, I'm not planning to deliver a master degree in cybersecurity within this section. But there's a lot of area that we need to worry about, like software composite analysis, static application security testing, and dynamic application security testing. I believe these are the area that Snyk perform really well and add tremendous value for your team. There's also interactive application security testing and runtime application self protection as well. Now, each of this area require a lot of time and investment to understand and implement properly. But obviously, at AWS, we do have a team of security specialists, and myself included, which will be more than happy to support you if you have any particular need. Feel free to reach out again. And then that leads us on to enforcement of the pipeline, right? What I mean is that you need to establish, or you should establish different environment like sandbox, dev, test, and production. So obviously, don't run your production code in the same development environment, and make sure that the user should have the least privilege, or increasingly fewer right as you progress through environment. So what it means is that the developer should have a lot of privilege and right in the dev environment, a little less in test, a lot less in staging, and then really limited right in your production environment. And ideally, only the pipeline should be able to make change to production, instead of someone logging into a server through SSH and then do different kind of scripting, or someone manually deploy a binary into your ECS or EKS cluster. We should try our best to avoid that. And I'm going to just show one of the I'd say example of how we do enforcement of the pipeline. As you could see over here, I'm leveraging different AWS account, one for tooling to host the tooling, and then one different account for development, another one for test, and then the last one for prod. So we have segregation of concern. We reduce the blast radius, and we contain each of the software development lifecycle state within its own account. So if there's anything wrong happen, that problem is contained within that environment, within that account, right? So the point is really try to create good architecture for pipelines, separate environment by their access level, and limits the blast radius, right? So in order to implement a proper Devsecops practice in place, there are some, I'd say, tip and trick that you should pay attention to than other area. You want to think about how you leverage testing tool, code review tool, or scanning tool, and integrate them very easily into your existing pipeline. Because if it is hard to use, right, if it is not intuitive, your developer or your cell are not going to use it, right? And then you need to be able to track of this finding. You need to be able to manage them and make sure that there's nothing can fall through the crack, leaving your organization exposed. So those are I say, one of the two very important area that Andrew and Craig gonna show you how Snyk and Atlassian add value and help you out in those areas. And I'm gonna finish my part by leaving this reference architecture. So this is obviously a lot of AWS native service going all the way from our CodePipeline, code view, and then deployed into EKS, and then monitoring using CloudWatch, and having all the security event centralized in Security Hub. But obviously, if you're not using any of this native service, but you're on AWS, you still can plug and play. Instead of using code commit, you can use BitBucket. Instead of using AWS code view, code deploy, you can use BitBucket pipeline. And all of this, orange gear that I put here for secret scanning, SAS, DAS, and Rust, all of those are where you're free to choose your tool. And obviously, within the scope of this webinar, I would really highly recommend using Snyk because they Snyk fill in all this area and then provide value. And what I love the most about Snyk is that it is so simple to use. It's super intuitive. So whenever you want to integrate Snyk and Atlassian into your existing pipeline, those would be non-intrusive change. And you can still carry on your day-to-day work instead of you have to stop and then revamp the entire infrastructure stack just to install Snyk or Atlassian. So with that, I'm gonna leave this here and then hand the control back to Andrew and Craig so that they can explain more how Snyk and Atlassian add value. And Craig gonna continue on with a demo a little later. Andrew, the stage is yours.
Thanks, Tony. Appreciate that, man. All right, cool. So hi everyone, I'm Andrew, I'm the product manager on the Atlassian team. And what I want to do is kind of take all that detail and talk about what does that actually mean for your development team when they're working on the tools that they interact with every day. As Atlassian, we pride ourselves on turning small development teams into large ones. And from that, we've kind of inherited the responsibility on how do we educate these growing teams about best practices and also offer solutions in workflows that customers can easily implement. And that's why Atlassian and Snyk have kind of really come together. We've identified that problem that Gartner has spoken a lot about, that 70% of open source projects have outstanding vulnerabilities. So how do we make that a shared responsibility amongst the team to take everything that we've spoken about today across Devsecops and identifying the pain points and areas about this, and how do we look at it in the infrastructure layer, to then what do developers do every day, action by action as they commit code, to actually stay conscious around security. So for Atlassian, that means meeting developers where they work. Within BitBucket, we've partnered with Snyk here to have a real focus on two kind of actors, that being developers themselves that commit code every day, and number two, the security analysts that keep an overview of everything that's going on at the code level, right? So there's three approaches that we've taken to that, and we're going to actually go into our demo today and explore these use cases. Number one is a security tab within BitBucket that exposes scanning reports from Snyk against a repo. So everything that's going on within that repository, all of its potential vulnerabilities are summarized up at that repo level, right in the tools that your developers use every day. Next up is PR analysis within Code Insights. So as your team members push PRs into BitBucket, we want to catch those PRs at the incremental code level and make sure that we can expose, is that code actually going to bring into a vulnerability? This means that our developers on our teams can remain really proactive about the work that they do, right? They see security vulnerabilities right before they come into that code base and merge into master. And lastly, towards the end of the development process, we look at BitBucket pipelines through the activist Snyk pipe as a way to then ensure that fixing and monitoring occurs downstream as well. So after that's deployed, are we going to remain to test and monitor it and look at the vulnerabilities that come up outside into containers and also just overall at that repo level as well. One element that you won't see in the demo today that I thought would be nicely to pull up here is actually how do you quickly start, right? If you're a team lead, if you're a developer, a dev lead, and you're seeing that this kind of act around being really vigilant around security is something that you want to implement into your workflows, actually within BitBucket today, you can jump into our security tab and then really quickly install Snyk and get these features right added to your developer workflow. So really simple setup process. And now I will invite over Craig so we can actually kind of deep dive into what does this actually look like in BitBucket and lead you through some of the experience. So I'll welcome Craig to the stage.
Thank you, Andrew. So I'm just going to switch over now to my my demo. I hope everyone can see that. Is that fine for you, Andrew?
Yep, I can see it.
Okay. All right. So to start the demo today, what we're going to look at is we have obviously BitBucket. We're using BitBucket Cloud here. We have an application that we have under source control called Goof BitBucket, which is a to-do application that we've written here at Snyk. And as you can see, we're going to we can see all of the different aspects of that project. So all of the source files are available. And we can look for vulnerabilities in that particular project itself.
Yeah. So to take the first step there, and I'll join you in on this one, Craig. Let's go have a look at one of those let's click into the Snyk tab and actually have a look at the vulnerabilities against this entire repository. So here we can actually click down into the package.json file and have a look at everything that's on the open source vulnerability side of the fence. And here what BitBucket and Snyk give us is a severity rating level against every single vulnerability that's been identified. Here we can see that high, medium, low severity level found out of those full 93 vulnerabilities against this project. But if we jump into one of them, what we can see is actually how mature is this exploit. We see that our vulnerable version is 0.4.7, but this was something that's actually been fixed in the later iteration of this open source library. So what we want to do with this zip slip vulnerability is actually try and repair it. So let's click into Snyk here, and we can actually have a look at a little bit more details about this vulnerability. And through the Snyk UI, we get an opportunity actually to fix this vulnerability through a pull request. So we see its score, we understand that it's something that we want to deal with now as a team, and we can click through there to fix that vulnerability and create a PR within BitBucket. So I'll just take a moment for us to do that. As it loads up, I'll talk through some more here, which is that this is a great way for security analysts to push through PRs on long-standing vulnerabilities that they've seen against their repository. So if this is something that the developer themselves haven't called up, this is a great interface and a great overview for those security analysts or an engineering manager or a lead developer to step in and go, all right, I want to make sure that my team start to look at these pieces of work. I'll push over those PRs themselves. Let's maybe just pick another vulnerability there, maybe the one below it. Always the fun of demos.
Okay. So that was Lodash. Okay, so that's now generating another pull request in order to update that library from the vulnerable version to the non-vulnerable version. And I think that's worked.
So now here you get that full, really detailed description within the PR. So there's always context about what work's being added to your repository. And as we scan down, we can see kind of what actually is that diff against this code. So we see there the versions that have been changed. And then when we feel comfortable with this, we can approve it. What also happens to note about the Snyk integration into BitBucket is that once your developers are actually introducing code, on the right-hand side here, those builds passed and tasks can actually create reports, just coming up as that new element there. And Snyk will print out any vulnerabilities found against the incremental code that you've delivered to the code base. So with an overview there, we can obviously click to approve and then merge it and then build. But on the build side, before we jump into that, let's, for the sake of the demo, go into the source view and actually have a look at our BitBucket YAML file. So one of the things I discussed in the overview beforehand was that BitBucket pipelines is an element that also can help us look at container scanning and overall just monitoring of our platform. So here we can click edit. And if you're new to BitBucket or new to BitBucket pipelines, clicking this here actually allows you to get started with Snyk really quickly. What you'll see on the right-hand panel as this loads up under add pipes, the integrations option, is that there is actually a template that already exists for Snyk. So you can add in any of the differences or steps or any kind of customizations you want to put against that template and run straight away with Snyk integrated into your overall system. So what you've seen here today is 3 different ways to interface with BitBucket and Snyk right within BitBucket itself. So thanks Craig, for leading us through that bit.
Okay, thanks Andrew. That was great. So let's assume that now we've imported that. We've got our application. We've scanned that application. We found out what all our security vulnerabilities are. Snyk's helped us to fix those vulnerabilities by generating a fixed pull request. We've gone to merge that back into our master branch. And again, Snyk and BitBucket together have checked that PR because it might be a developer making a change to the project. So it's another capability with this integration is if a developer's making a change, when they go to check that change in, Snyk will make sure that change is not introducing a new vulnerability, and you can actually decide whether you want to accept that change or not based upon the output of the security report. And what we refer to that as stopping the bleeding. So while you're looking through the existing vulnerabilities and working out a prioritization approach to fix those, we want to make sure that new vulnerabilities aren't being introduced. But in saying that, once we've got the application to a state where we're comfortable to deploy it and we deploy it, we might containerize this application that we're seeing and possibly push it into a Kubernetes cluster on AWS. So push it into EKS, for example. The good thing here is that we're also able to now use Snyk to detect the containers and the applications that are running in our cluster and scan those as well. So the idea here is that Snyk gives you the opportunity to embed the security scanning at the stage that makes the most sense for you as a customer. That could be right up front while you're coding in the IDE. It could be in the SCM, as we saw earlier. It could also be with the pipelines to have a step in the build. But now we're looking more on the right side. We've got things running in production. We also want to make sure that they're not affected by maybe new vulnerabilities that get discovered. So as what we offer here is a controller that you can deploy into your Kubernetes cluster, and that will detect the running containers and provide a scan of those. You can see it's the same application that we saw earlier, but this time we've got it running down in the cluster, and via our Snyk UI, we're able to go and inspect not just the vulnerabilities in the open source, but also the container vulnerabilities in the container image itself. So, you know, as we saw earlier, if I went into package.json, we're going to see those same sort of vulnerabilities that we saw earlier, and we can get all the information around there. But this time, we're also able to look at the container. So you can see this is using a Debian container. It's a node-based container, and obviously it's going to have its own vulnerabilities, and they could be either the system libraries, so the operating system stuff, but they might also be the node layers, so the other layers that are applied on top of the operating system. And using our filter, we're able to see what those vulnerabilities are, how they were introduced, and importantly, how to fix them. Now, as developers, you're probably not going to sit back and then, you know, fix all of the vulnerabilities in the container. You might decide it's a better use of your time to look for a more secure container image to use as your base image. And so we provide at Snyk, we provide recommendations for other base images that might be better suited for your requirements as far as security goes. So you can see here, current image. So this one that we're running in our cluster is using node 14.1. It's not a very secure container image. It's got 968 vulnerabilities, and of those, 45 are considered critical and 171 are high. So it's a very insecure container. So here, you know, if we just did a minor upgrade to node 14.19, for example, we can halve the number of vulnerabilities, and importantly, we can severely reduce the number of criticals and highs. Still not perfect, but better. But then we can look at, you know, other options. So a major upgrade to node 16.14, that will get rid of all of our critical vulnerabilities and reduce the number of highs down to 12. Or there's alternative images. So some of these slim node images are really quite good. You can see there that, you know, the first one, node 14.19 Bullseye Slim, only has 44 vulnerabilities, no criticals, no highs, no mediums. They're all low, and that would be, you know, quite appropriate to use, assuming that the slim version of the container has all the system libraries that your application needs to run. On top of that, what Snyk can offer is the ability to look at your Kubernetes cluster configuration. So if I come back out here, and this time if I click in on the at the top level on the cluster, we can look for, you know, configuration settings that may be, again, putting you at risk. So for example, in this particular cluster, we've got containers that have the ability to run as root. Now that's quite dangerous. It's not a very good configuration, and it's if you look at the CIS Foundation's benchmarks for things like Kubernetes, they'll recommend that, you know, containers don't have the ability to run as root, because if that container was compromised, an attacker could potentially move laterally through the cluster with root privileges and cause a lot of damage. You'll also see here that there's no limits set. So, for example, we haven't set any memory limits or CPU limits on the cluster. Again, that exposes us to a denial of service attack where we can have attackers chewing up all the resources that then don't allow our containers to run as they should. So again, this is looking at what's running in production. You probably want to find and fix these problems earlier. So that's where the Snyk infrastructure as code scanning product comes in. It will actually scan your YAML files before you actually deploy your containers or deploy your cluster. And it'll alert you to problems that will eventuate if you don't fix the problems back in the YAML file. Similarly, we can use that product to look at Terraform templates. We can tell you if your EC2 instances, for example, are insecure. Maybe you've got an S3 bucket that's not encrypted, or a security group that's more permissive than it should be. So that is that's part of the Snyk infrastructure as code product. The only other one that I should mention that we haven't touched on is our SAST tool, which is Snyk Code. And it will look at the custom code that the developer writes. If I jump over to one of my other projects over here, this same Goof project that we have, you'll see that simply by importing the repo, that's the BitBucket repo, into Snyk, it's already detected based upon the artifact types which Snyk product to run in order to get the security reports across the 4 different aspects. So you can see at the bottom, we've got the open source stuff. We've also got some Terraform templates up there. You can see there's an EC2 template. There's also a CloudFormation template under source control. And by clicking in on those, we can look at recommendations, issues around our EC2 resources. Not just the issues, but again, how to fix them. The important thing with Snyk is it's always going to give you remediation advice so that you can go through and fix it. And the important thing to consider with infrastructure as code is even though this is now something the developers might be responsible for, they may not have come from that infrastructure world and may not know, one, that it's a problem, but two, how to resolve the problem. So all of that advice is provided within the Snyk UI, the settings that you would need to adjust in AWS in order to secure that particular vulnerability or misconfiguration, as it might be. You'll see also in here that we've got the SAST product that I mentioned a minute ago. So if I go into code analysis, what this report is doing is it's looking at the custom code that the developer's written, and it's looking for vulnerabilities in those lines of code that the developers created. So it's a SAST tool. It looks for things, as you can see here, hard-coded secrets. We've also got SQL injection, command injection, resources that don't have limits. So again, if we drill into one of those, we can start to address the issues in that custom code. So here we've got this SQL injection problem. Maybe I'd like to learn a bit more about SQL injection. Maybe I don't have a good handle on what that actually is and how to avoid it. So you can see here, Snyk Learn. That will provide me with a page describing the basics of SQL injection, what it is, how to avoid it. But also we have these widgets that allow you to try it out. So we've got little SQL injection test pages that you can use in order to see what happens when a SQL injection gets exploited. But obviously we want to point you to how to fix the problem that you have. So in here we can click on the details, and this will provide details around the flow. So how does it flow through the application, the control in order to arrive at this particular problem. So you can see from source to sink how it gets there. But over on the fix analysis page, what we're going to do here, and the way that Snyk code works, is it scans using its machine learning engine. It scans all the public open source applications that are out that are publicly available. So on things like BitBucket, And we look for SQL injection examples in those applications. And then because we're continually scanning, if we notice that a developer has fixed that problem, in this case, SQL injection, we'll position that fix to the developer to give them an example of how they could rewrite the problematic line of code in order to get around the SQL injection issue. And so here on the right-hand side under example fixes, I can see that there's a project out there called Mozilla Napkin. At some point, we discovered a SQL injection issue in that application. And then on a later scan, we saw that the developer had fixed it. And this is the line of code that they changed and the change that they made. Now, that might be appropriate, but then we also position 3 fixes in total. So the developer can look for the one that is most suitable and perhaps use that as a source of inspiration to go back and fix their own particular issue that they're having. So that's Snyk code. And that sort of covers off the 4 different aspects of Snyk. So just repeating, we've got Snyk open source, which looks at open source libraries and their vulnerabilities. We've got Snyk container. That's looking at the container vulnerabilities, and that could be the container, the Docker file. So looking at the base image that's being used and providing recommendations for alternatives. We've got the ability to connect to a container registry. So if we wanted to look at, for example, ECR, and we had that Docker image that we saw running in Kubernetes earlier, we can actually scan it while it's sitting in the registry. So before it gets deployed into production, and look at fixing it there. And then the third place for container is obviously by installing the Snyk Kubernetes controller that will detect running containers and provide security reports around those. That's the second product. The third product then is Snyk infrastructure as code, looking at misconfigurations in templates, whether that be a Kubernetes template, a Helm chart, a Terraform, or a CloudFormation. And then finally, Snyk code, the product that looks at the code that the developer's written and providing in a very fast, immediate feedback way, the ability to understand the vulnerabilities in the custom code. So that brings us back to the wrap up. I hope you enjoyed the demonstration. I hope you got some value out of the whole session. I'd like to thank Tony from AWS and Andrew from Atlassian for helping with the session today. And I might then throw back to our facilitator. Cody.
Well, Craig, Tony, and Andrew, thank you so much for taking the time to join us today. A quick reminder to our audience that the session was recorded. So following this webinar, you'll receive a link with an access link to watch the on-demand recording. You can also find it on the DevOps website at devops.com/webinars. I'm not seeing any questions that came in today, so I think you guys just about covered everything. So I really appreciate the depth that the 3 of you went into with this topic. So again, thank you guys. We do have 4 gift cards to give away, 4 $25 Amazon gift cards. Our first winner is Sam F. Our second winner is DDJ. Our third winner is Salim A. And our fourth and final winner is Jayendran S. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't receive that email, just check your spam folder. I would like to thank Snyk for sponsoring this webinar. And my final thanks, as always, goes to you, our audience. We really appreciate you taking the time to join us today. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future Techstrong Learning webinar. Have a great rest of your day, everyone.